Who haven't signed yet?
Siri, is this good for you? You believe it yet? Can you do it? Can you do it in the test? Of course you can do it if you print the slide, right? Next exam is open book. Can you do this all derivation? Yes, it's open book. If you cannot do it, what does that mean? You didn't print the slide. Okay, I cannot test you on this for open book exam. I can, but if I do, you should get it done correctly. Just copy and paste. Write down. Oh yeah, you need to know the meaning about it. So this one, I have d by dx of 1 over u is what? Minus 1 u to the power of minus 2 du dx, right? Minus 1 is over there. U 2 minus 2 is that thing. Du dx is HRTD prime. Just that. Right? Maybe. Oh. Did I do it right? Okay. A little bit more step over here. We do some kind of chain rule. We try to take the derivative with respect to z, right? So we do, this term that I say prime is dh by hf, small h, and dhf by dz. That is chain rule. Okay, so this multiplied by that is d whole up by dz. Right? So I have chain rule to make it to split whole up and height. So take the derivative of whole up with respect to z is whole up with respect to height and height with respect to z.
That's whole up with respect to height.
H prime is whole up with respect to height, yes. And height with respect to z. So multiply them together is the same as whole up with respect to z, right?
For that height, hold up present. That's supposed to be 0.
So
Oh, yeah, hold up.
d by dz of 1 over h is minus 1 h to the power of minus 2 and dh by dz. You get that, right?
No, yeah, say hold up is changing with time. On spot.
Whole up change with z.
Yes.
So
How can you find the derivative of hold up?
and height. Okay, I'll show you. So basically we have minus 1 over h square multiplied by dh dz, and we split dh dz to be the capital H by the small h and multiplied by the small h by dz, right? How do we take the derivative between whole up and height? Is the whole up a function of height? When h altitude is 1 or height equal to capital D, whole up equal to 1, right? When height is 0, whole up is 0. So height and whole up, they are related. So how do I take the derivative between whole up and height? How do I do this? Can you tell me? Okay, next page. You will eventually be able to do it. I skipped 2 slides and I show you over here. You see this? dHRTB by dHF. HRTB is AL over AP. AL is that. AP is AP. And student has to, we start from this equation. Okay? And you show that dH by dF is that. Similar to the exam, right? If you recall, dAg by dHL equal to minus Si. You can use this one, right? And start from here take the derivative with respect to h tilde first and the h tilde by the h later. You get this. So it's not about how can we do it. It's about can you do it before the exam?
Is it HF?
This is the answer. This is the answer. dh by the small h, and that's the answer. We start from here.
So
Is it HF and HL is this same?
HF, HL, yes, same. In this context, they are the same. So this is a solution. 4 over pi d square root something something something.
but you can certify for what and apply it to the same session.
Yeah, you can say it's stratified model, but it's not stratified. It's like geometric relationship. Take the derivative with respect to h, and then you get this. Okay. Do you believe it? Do it. Okay, do it. Do it before Monday, after next Monday. How's that? Vega, did you like it? It should be very easy, right? Because you have done similar thing already. So let's go back. So we have from our governing equation we have this 3.104, and we know that x is relative velocity. If we look from the slug body, is relative velocity multiplied by rho AP HLLS, and x not equal to xz, or x is not a function of distance. Okay. Put everything back. Okay, start from previous equation that we already have. That's equation, right? And we know last term is this. Okay. And we know that first term is that. Put everything in, rearrange, we get 3.105. That one. Okay. So this is the HF by the Z equal to minus tau F SF. What do I read this? You can read this, right? The meaning of this equation is you can get the shape of the film. Ta-da! Don't like it yet? You can you can get the shape of the film. After you do sigma F equal to MA, get the expression of sigma F, which is VD MDT, put VD MDT in, take the derivative with respect to distance, take the derivative of the right hand side term, do everything, then you get that equation. So left hand side you have HF, right? Right hand side you have tau F. Do we know tau F? Tau F is a okay, we explain later. We have tau F, SF, A, whole up, fluid property, 9.8 sin theta, x squared, rho AP HL2, not HL2, whole up, HLTB squared, HLTB prime, AP HLTB rho G cosine theta. Everything is a function of small hf. Why do you say that? Okay, let's take a look at it term by term. So I already explained h prime, HLTB prime is that term, right? And that term is a function of height. Good. So if we know height, we can calculate HLTB prime. Is this this is a solution over here, this solution over here. You may even need to do it. Just have to print the slide. Okay, easier, right? So DAF by DHF is SI, not minus SI, or did I miss a minus sign or something? Oh, that's AG. This is AL, A field. DAF by DHF is SI. Okay, DAF by DSS is FI. Do something, get that. Not very difficult when you see solution, right? But take a look at it. That's how we do it. For AL, take the derivative, same as in the exam, add everything together. Can you do it by now?
Now?
Is it what?
Can you do it?
Can you do it quickly within 15 minutes? No, without practice. You can do it. This is easy enough for you to do it. This is, read it, okay? And you can do it. This is an explanation, you can do it. You have done it already. You still want to go back? We are at this equation. That's the same equation. That is the equation. Come to see me after class, how about that? Okay. It is correct, and it is the same as in your book. So we have HLTB prime. HLTB prime is a function of HF. HLTB is a function of HF, right? AL over AP. AL is a function of HF, right? So HOAP in the Taylor bubble zone is a function of HF. Okay. What about tau F? How do I calculate tau F? Tau F is on the film part, friction factor rho v squared over 2. Notice that I don't use relative velocity. I use real velocity, even though I am in the moving frame of reference. Force is invariant for non-accelerating frame of reference. Okay? So VLTB is VTB minus VF squared. Okay? And friction factor, that's friction factor, right? Friction factor is CDL, which is a function of height. VTB minus VF multiplied by rho over mu. Okay, so we have VF. And we have VF over there. Alright, that's Reynolds number and tau, shear stress. What about, yes?
So that means from the one of just if we actually use dimensionless term, you still get the correct answer. Because what you just showed is that the things you used to get SI and other things get just a function of geometry and not the function of the diagonal.
Roughness, it is. This is for, whenever you use Blasier's type, it is only for smooth pipe. This derivation is for smooth pipe. You see, C multiplied by Reynolds number raised to the power of something, that's Blasier's type. It's strictly for smooth pipe. If the pipe is rough, you want to do it, then you can calculate it numerically. Okay. So let's go back to governing equation. We have VF inside Reynolds number, which is inside friction factor of film part, which is inside tau F. Okay. How do we express VF? VF is VTB minus VLTB, which is X over that whole thing. Okay. And what I write here is X is VTB minus VS and something cancel. So we have that multiplied by HLLS divided by HLTB. HLLS is 0.6. Not 0.6, but that's come from closure relationship. Okay. HLLS hold up inside the liquid slab. And I said VF, which is the relative velocity, is a function of hold up inside the film. And that hold up is also a function of HF, right? So VF is a function of F and X is a function of HLLS. So we need the input of HLLS, hold up inside the slug body, even though we do the calculation for the film. Okay? So V is a function of H, tau is a function of V, and a function of H. So everything here is a function of HF. Left hand side BHF by dz equal to some big function, but everything is a function of HF. Okay, who took numerical method with Dr. Moss? Akin, right?
I'm taking it.
You're taking it. Okay, those who taking it, Tolani, right? I asked many questions for Akin already. Okay, Tolani, how do you solve this equation numerically?
I'm going to put into my math and do
What name of function that you have to call?
function that's called for that.
What kind of numerical method? Yes, the numerical method.
I probably do like maybe bisection
Bisection, no.
or Rams using something.
Newton-Raphson, no hybrid.
I don't know what.
Okay, what about people who didn't take the numerical method with Dr. Moss? Maya, what method did you use to solve this? Probably what? No answer, right? Sweta, how do you solve this? RK for 5, yes! Okay, you keep until that point, he will talk about it, okay? Use RK for 5. dy by dt equal to a function of y and t can be solved numerically. RK for 5 or RK for. If you don't use all those fancy methods, and you can do just Euler method, what do you do? One very simple method that you can do in the Excel sheet is this. So we start at z equal to 0, at the tail of Taylor bubble. Okay, z equal to 0. At z equal to 0, we know the height. Height is hf, right? We can calculate height from whole up of HLLS, right? Can you translate whole up to height, height to whole up? Not a question, right? Use cosec, right? Okay. And the right hand side term, everything is a slope. This is the slope of film height with z. It is just a slope. Okay. So if we know, we start at this height, we move in plus z direction. So if we know the slope, okay, let's say we start at higher point, not that, okay, that one. We calculate the right hand side. Right hand side can be calculated, right? If you know the height, right hand side can be calculated, and then you get height. So if you know slope at that point, you can extrapolate to the next point. Extrapolate shortly, and then you stop. So you stop at that point, right? You calculate right hand side again, which is the slope of the film profile. So next time you get this slope, you extrapolate the slope, you get that. You do several of these, you get film profile. First you get the slope, you extrapolate the slope, and you consider those as your answer. Once you reach the next point, you calculate the slope again, and then you extrapolate it, and you consider those things as your answer. This is, of course, wrong, but it's a good approximation. If you discretize more, if you jump short distance, eventually you go approach the exact solution. Okay? Akin, does it make sense? Yes, okay.
We have the available package for RK45, so you don't have to write it like C++ from the scratch.
Correct.
So it's
And in MATLAB,
in MATLAB.
you also have that, right?
In
In C++, you also have that too. Do you have
Why
that?
didn't you tell me? Because if you didn't have it, I had to write all the code for myself. But with
Yeah, that's
MATLAB-
what I want, yeah. You write the code of yourself.
That's what I'm saying. In MATLAB, you just have to write the function.
What about Armadillo? Does it have this?
RK45 doesn't?
You always have library to call in whatever kind of programming language, and call the library. MATLAB easier to call the library. What do I want? I want you to write the whole thing. Okay. So we can solve it. Okay, let's take a look. Something that we need to know before we solve it. You see, it have numerator divided by denominator, top part and bottom part, right? Sometimes your film look like this. Okay, so the slope at that point is infinity. Put infinity into computer, it crash. Doesn't work. Okay, so we have to avoid that. So what the approach that Douglas Hubbard uses. Okay, let's clean the screen. You see the denominator, the bottom part. So if this thing, cannot close it. So if the bottom part equal to 0, this means what? The slope is infinity, right? So this means we have some kind of that kind of curve. We have this kind of curve. This can happen, especially high viscosity oil. When it's thick, it's formed like this. Okay. When you have that kind of curve, the solution that you get is from you do the force balance, right? When you do the force balance, there's a force balance from the bottom part. Whatever you get, it is for the film profile of the bottom part, not the top curve. So if we have something like this, we have to start from that point. Okay, that is the point that we have to start. Not that height. If we start at that height, it's gonna move backward. Cannot solve. So in some case, critical height is there. In some case, it is not there, depending on VSL, VSG, liquid density, viscosity. Okay. So for the case that it is no critical height, you proceed as usual, no problem. For the case where there's a critical height, you start at critical height. So typically you calculate h at the starting point from HLLS, right? So critical height may be lower than that. So we have to select critical height which is lower than that. We cannot, so if your curve like this, you start at that height, it's not going to work. You have to start at that point and then move downward. If you start at that point, it works, but it's difficult to work because at that point your slope is minus infinity. This means you have to jump very short distance so that a little bit and then calculate again. I try RK45, sometimes it works, sometimes it crashes because of slope of minus infinity. So you may start slightly, numerically start slightly below the critical height. So the curve is that shape, right? Slightly below, the slope is not minus infinity, and in the program it works. Okay, RK45 also work, but not always. I have to change some kind of tolerance or something. Critical height set the bottom part of the denominator equal to 0 and solve for h value that make the bottom part go to 0. That's how we get critical height numerically. So from the for the bottom height, for the denominator, you can use interruption bisection or change digit by digit to get the height that it works. Do you know how to do check digit by digit? So you check from, I explained your bodies already, right? You start from point 1, go to point 2, point 3, point 4. If it go beyond 0, you change the next digit, change the next digit. So you find HF that make the bottom part equal to 0, and that will give you critical height. Can you find it analytically? I don't think so. This have arc cosine or something. It is kind of difficult. Okay, but it can be found in Excel when you do it. Okay.
So when you get to critical height, that will be the point from which you start.
Yes, that will be the point where we start to calculate HF. Another part is, what about equilibrium height? Film will drop down, and at some point, it will be like that, right? So we call that equilibrium height HE. HE is when the slope is 0. Slope is 0 means this whole thing is 0. Or the top part equal to 0. The top part is that thing, right? Equal to 0. That is the point at which there's no slope on the film profile. Okay? How do we get that? Numerically, everything is a function of liquid height. We can change the liquid height until we find what liquid height makes left hand side equal to 0. Very good. You don't like it?
Yes, I think it's okay.
You think it's okay? Smile a little bit. I'm like, okay. Is this okay?
It's just my thinking face.
Yeah. It looks difficult, but it's not that difficult. So, one thing to mention. Now you can find equilibrium height, right? Let's say you do the test. You want to approximate what is a liquid hold-up inside the film zone. What is a liquid hold-up inside the film zone? Easiest method is say, okay, height in the film zone is the same as equilibrium height. And equilibrium height is minus tau f SF minus AP H rho G sin theta equal to 0. Then you can find liquid hold-up in the film. Isn't this great? Liquid hold-up inside the film is very important for the hydrostatic term, right? Very important. So by this method, use just one equation, which is that equation, get liquid hold-up or film height in the film height or HLTB. Yes, HLTB. Good. Okay. When you do actual calculation, there could be some problem when you calculate tau f. Okay, force is a vector. If your force is a vector and we use real force, because force in moving frame is the same as force in the stationary frame, right? So force is a real force. So what we have to do is, if your film move backward, tau go. If your film move forward, tau go into plus z. Sometimes film move backward, so tau go to minus z. Is going to the opposite direction of the flow, right? So away from the slug tail, film can move backward, and tau f actually move forward. Okay. To account for that sign change automatically, you calculate tau f by 1/2 f rho. Instead of v squared, you use VRTB multiplied by absolute value of VRTB. So let's say VRTB is positive. VRTB is positive. So this expression equivalent to VRTB squared, right? So tau f, the value will be positive. And when you put in your equation, you put it in, where did you put it? You put it over here, right? So positive value means go to plus z or negative direction of the flow for the stationary frame of reference. So it's take care of the sign automatically. So let's say your film move backward. Your film move backward. VRTB is negative. Negative multiplied by everything else is positive, right? So this term will be tau f will be negative. Correct? When tau f is negative, we put it back into our governing equation, that term. This thing will be negative. So this means tau f move into minus z. Minus z, which is the same direction as the flowing direction, right? That's minus z. Minus z is a positive for the stationary observer. Okay? So when you calculate tau, you may need to be careful. I did it wrong first time. Second time I know that, oh, this is a problem that make my program doesn't converge. So I change it. Another part that I know that we have to do is Reynolds number. Reynolds number is used to calculate friction factor. If velocity is negative, Reynolds number has to be the real Reynolds number, right? Based on VLTB, right? VLTB is VTB minus VF. So Reynolds number can be negative. So Reynolds number raised to the power of minus 0.2, you get imaginary number, crash. Doesn't work, right? So put the absolute sign over here. Okay?
Can you say it again,
V can be negative. Reynolds number can be negative. So when Reynolds number negative, Reynolds number raised to the power of minus 0.2, get imaginary number, program crash. Okay, doesn't work. So, or if somehow it is okay, then you get negative friction, which may interfere with this sign convention that we have over here.
Something is,
Which part?
because the original, very first slide shows, right? So,
Reynolds number is wrong.
not that, the VTB minus VF.
VTB minus VF. So we have VF equal to what? What is our definition for VF? VF is VTB minus VRTB. So if we want VF is the relative velocity, right? So if we want VRTB is VTB minus VF, which is exactly what we put over there. And we put it in that form because we can get VF from X, right? And X, we can get VF from X and HLLS and HRTB. And HRTB can get from height.
So you're saying VF can be greater than VT. Is that what you're saying?
Okay, look at this. VF. Yeah, why not?
No, it's not. But the only thing you can do is to say VTB negative, because VTB is going away from C, but working reference CC. That can be way now to go. So VTB negative, VF positive. Right?
So we have VF equal to VTB minus VLTB. So VTB is always higher than VLTB, right? Okay. So VF is
Positivity.
So-
direction. So are we solving with reference to Z or solving with reference?
if you Reynolds number is the real Reynolds number, not the relative Reynolds number. Look at this part.
I know, I'm not. That's
VTB minus VF is VRTB.
I agree.
And VRTB can be positive and negative. That's why I put absolute sign. So when I explain that it like that, when VRTB is negative, so VRTB is VTB minus VF, right? When we move backward,
That's
what is the relative velocity? Okay, if we move at the same speed of Taylor bubble, the relative velocity is zero. If any particle move at the same speed as VTB, the relative velocity is zero. If it moves slower, we define VF as VTB minus that thing. So VTB minus that thing is positive. But if it's moved a lot slower in the opposite direction, what do you have? It will be VTB plus VF. This is wrong.
No, what's the
Oh, this is correct, but we
what's the
still
frame
get
of reference? That's what the confusion.
real one, not the. We use real stationary frame of reference to calculate force.
So that means, see, VTB minus VF, because VF is based on how you describe VF. And
VF is positive value. VF is positive. VF is this. I have VF as
diagram, that's that.
this.
See,
VRTB less than VTB, so VF is positive.
no, that.
Positive in the plus Z direction.
What are we solving for now?
Oh, okay. So this is Reynolds number. We solve for the real Reynolds number. It's kind of confusing, right? That's why I put the absolute sign to make it always. So we don't consider the direction of the force within Reynolds number calculation.
Okay.
That's the part.
So now we'll go back to where we are supposed to be at.
So how about I explain it like this?
No,
We don't consider the sign,
right,
and to not confuse about any sign, we put absolute sign.
right now,
Yeah.
we are solving with reference to Z direction. Frame of reference here.
Yeah.
Yes.
Yes. That's the actual. We don't we calculate the magnitude, but not the. Oh, it's times up. Oh, okay.
You said nothing is greater than VTB, so how can I do if you subtract?
So how about this? We continue the discussion next time. But the only thing that I remind you is when we calculate force, we calculate from stationary frame of reference, and we calculate just the magnitude, and the direction we consider it separately to not make it wrong. Do the homework. Homework is not hard. It's easier than this. Okay. See you next Monday. Bye bye.